Hello, and welcome to the Excerpt. I'm USA Today national correspondent Elizabeth Weiss. Back in May, the National Oceanic and Atmospheric Administration, or NOAA, predicted a record hurricane season. And while it started out pretty quiet back in June, we're certainly there now. The cataclysmic devastation of Helene and now Milton have cost hundreds of lives and caused billions of dollars in damage. And there's still a month and a half to go in hurricane season. What's behind these supersized storms, and perhaps even more urgently, what's next? Here to help me understand all of the forces at play is Ghassan Alaka, Director of the Hurricane Research Division at NOAA's Atlantic Oceanographic and Meteorological Lab in Miami. Thank you for joining me on the Excerpt.
Happy to be here.
So let's start with the historic nature of these two most recent storms, Helene and Milton. Hurricane Helene made landfall in Florida with a record storm surge and devastating winds before it went on to dump catastrophic amounts of rain in the Appalachian Mountains, causing deadly flooding inland. Now, Milton weakened, thankfully, before it made landfall, and we avoided the worst case scenarios, but it still has caused at least 11 deaths. So let's talk about the forces that has led to these storms. And let's start with the significantly warmer Gulf waters. What's happening here?
Yeah, the ocean temperatures have been much warmer than average all throughout this entire hurricane season, actually dating before the hurricane season back to last year even. Very, very warm, near record ocean temperatures in the Gulf of Mexico and the Western Caribbean, but also for much of the tropical Atlantic in general. We have been keeping a close eye on the Gulf of Mexico as sort of a place that's primed to produce very strong hurricanes because of that ample heat that's in the ocean, which of course is the fuel for these massive storms to feed off of.
And the intensity of these storms, particularly Helene, in terms of wind shear and the amount and the rapidity of the rainfall, and also the storm surges, these were crucial to the damage that they've caused. From a scientific perspective, what's to blame? And is that ocean warming, is that also impacting this?
I think looking at Helene and Milton, both, devastating storms, but two different storms. Helene was really, really large, whereas Milton was a little bit smaller, at least in the initial stages, right? It just goes to show there's a number of different pathways that we can get to, unfortunately, a devastating event and landfall situation. As I mentioned earlier, both of those storms fed off of the very warm ocean waters. I did want to highlight, we usually categorize our hurricanes based off of the maximum wind speed. We call it the Saffir-Simpson scale. If it's a category 3 or above, we refer to that as a major hurricane. But in general, one of the things that we've been learning is that the hazards obviously extend far beyond the maximum wind and the wind damage. Two of the most important hazards that aren't captured by that scale necessarily, if you call something a category 3 hurricane, is what exactly is the storm surge going to look like in terms of what footprint, how wide of an area is going to get that surge. We saw with Helene, a very, very large area had significant storm surge, even hundreds of miles away, all the way down the Florida coast, down almost toward the Keys. On the flip side, Milton was not as large of a storm. And so even though it was accompanied with some pretty devastating storm surge, it was not as big of a footprint as it was for Helene. Beyond that, the rainfall is a huge hazard that is not captured. Again, if we call a storm a category 3 major hurricane, it doesn't necessarily tell us what to expect in terms of the rainfall. With Helene, we had a very fast-moving storm initially that plowed right in, to the Florida Gulf Coast. But because of that fast motion, it was able to make it pretty far inland before it really weakened significantly. Typically, these storms, those strong winds, don't really make it that far inland because they're moving slowly enough that friction and other things that start to wind those storms down really take hold. With Helene, we saw very, very strong winds and high wind gusts all the way in through Georgia, up through the Carolinas, and obviously created a very devastating scenario on top of that, extraordinary amount of rainfall. So the rainfall is a big element as well. And looking at Milton, we saw a similar story where as it moved across the state and sort of it interacted with another weather system, it became more asymmetric. And so when I hear a category 3 storm is going to make landfall, I'm obviously very worried. The next words out of my mouth are, how big is the storm and what do the other hazards look like? Because at the end of the day, the wind is certainly a killer, but the water, both in terms of the freshwater flooding and the storm surge, is really what contributes the most to damage and death.
I mean, we certainly saw that Helene caused more damage much further inland than was predicted. Are we to the point now where families who are living in the mountains who might not be expecting that the remnants of these hurricanes are going to threaten their lives and destroy their homes? Is this something that we need to expect moving forward?
I would say I definitely would target more if you're living on the coast to be much more mindful of that. But I think from a messaging perspective, one of the things that NOAA is trying to get better at is messaging about these other hazards. And sometimes I think that, like I mentioned earlier, the talk of the category, which is based off the wind, sort of dominates the discussion. There were some very compelling forecasts showing how devastating the rainfall totals could have been in, western North Carolina and Tennessee and South Carolina and even Georgia. But I feel like in the way that the messaging got out, the category of the storm and the size of the storm sort of got all the headlines, and sort of this inland impact sort of took a back seat. So my question sort of becomes, how do we sort of retailer the message? A lot of this information is out there, but how do we retailer the message around that information to make sure that the right information is getting across at the right timescales? How do we better communicate all of the hazards instead of letting the category of the storm sort of steal the headlines and draw attention away from the water?
Thinking about the ways that we categorize hurricanes, and that's a category system that was introduced just over 50 years ago. But hurricanes back then feel at least like they were different from what we're facing today in terms of wind shear, storm surge, rainfall, as you were saying. Are there thoughts at NOAA about updating that category system to add more dimensions to give the public more information?
There's been some discussion, but at a very preliminary, like research-based level. So not anything on the operations side that's moving forward, but it's definitely something that, on the research side, we've chatted a lot about, going from one dimension to three dimensions and how to communicate that in a clean way. But ultimately, I think a starting point would be to, perhaps stick with the category system that folks are somewhat familiar with, but find a way to apply categories to the other major hazards. You said, okay, it's a category 1 in terms of wind, but there's a lot of moisture associated with this, and rainfall could be significant. So it's more of a Cat 4, Cat 5 when it comes down to rainfall effects. How you arrive at what category to call it, I don't have an answer on that yet. But I do think that people would be able to adapt to that type of three-pronged scale and say, okay, now I have a better idea of what the different threats are, as opposed to saying, all right, so it's a Cat 3, what are the other threats, right? And I feel like folks are scratching their head right now about how exactly that works.
Maybe we can talk a bit about the impacts of Atlantic currents and the trade winds, both of which have been evolving and shifting in recent decades. Like, how are they changing and what effect is that having?
I'd say in general, they're changing every year. And one of the things I notice more in terms of these weather patterns is more of a dependence on, shorter time scale events than really talking about long-term climate change. I'm thinking more about things like the El Nino Southern Oscillation. When those patterns, El Nino versus La Nina, for example, set in, those tend to have a much bigger, indication in terms of what type of season we're going to have, going from the favorability of conditions to the tracks that the storms and the sea disturbances to those storms might actually take as they move across the Atlantic. I think that's the way I think about the larger scale weather patterns. In terms of longer term trends, looking at the ocean temperatures and how those have sort of continued to creep up over time, that's something that I don't think is going to change year to year, at least anytime in the short term. We're going to be dealing with these really warm ocean waters throughout much of the Atlantic for a while.
So Miss Piggy is one of the 2 Lockheed airplanes, also known as Hurricane Hunters, that NOAA uses to study them. And Miss Piggy visited Milton last Monday. Were you there?
I actually was not there, although part of me wishes I was. I was helping coordinate a lot of activities from the ground. When we actually deploy, is what we call it, we participate in these Hurricane Hunter missions as scientists, there's a whole number of tasks that need to be taken care of on board the aircraft and from the ground. And so when we're actually on board, we're making sure that the data collection is going optimally, that we're flying the pattern as well as we should, and that we're keeping in mind what we call situational awareness. So how is the storm evolving while we're actually in the pattern? And are there other interesting things that are occurring that we should maybe deviate or change our pattern to go check out? From the ground side, I mean, there's a lot of work that's being done sort of behind the scenes to make sure that dropson data, which are those cool instruments that fall out of the belly of the aircraft and collect temperature, humidity, and wind data as they fall down to the ocean. Those need to be processed and quality controlled. So it's really this huge effort that includes a number of people on board the aircraft and on the ground. And this year alone, I mean, we've been tallying up our hours. We spend easily over 2,000 person hours, supporting these missions from the air and from the ground. And that does not even include the wonderful crew that includes the pilots and the navs and all the folks on board the aircraft that are keeping us safe. That's just the science component.
I mean, the data that you're collecting sounds really important, but it also sounds like it'd be pretty terrifying to be up on one of those flights.
Yeah, it absolutely can be. I like to say every hurricane flight is a little bit different. There's not one size fits all. And sometimes the strongest storms can be some of the smoothest flights. And sometimes the weaker storms can actually be a little bit more turbulent because the way they're spinning up, everything's not really in concert or synced up yet. It's just one of those things that when you're in the moment and collecting that data, you're sort of focused on the mission at hand, and the crew does a wonderful job of keeping everyone as safe as possible, even when the plane is bouncing around, a fair bit. I like to say it's a negotiation that's constantly occurring between the scientists and the crew, where we're the crazy people saying, hey, we want to collect this data that's really maximum wind, let's say. So we want to maybe get to this part of the storm if we can. And sometimes we'll be able to get there in a safe way. And other times the crew pushes back and sort of says, not today, Gus. That's not going to be in the plans today. We're going to get everyone home safely.
So listeners to this program, they're of course wondering what's next for this hurricane season. We've got a month and a half left to go. What can you tell them? Yeah,
we're bracing. I'll tell you that much. We're bracing. We had a very interesting quiet period in mid-August to mid-September, which we're interested to go back and do some research into exactly what was happening there. And this will lead into how I expect the end of the season to go. What I expect for the rest of the year is I do expect it to be pretty busy. The NOAA seasonal forecast, as well as other forecasts for the season, indicated, that we could be upwards around 17, 18, maybe even 20 named storms. We still have a little ways to go to get to that number. But as you mentioned, I think at the start of this podcast, we have about 6 weeks left in the hurricane season. So there's still plenty of time. I'm certainly going to be keeping a very close eye on the Western Caribbean and Gulf of Mexico in these next 6 weeks. And sometimes the season can shut down a little bit earlier in November. And this year, based off of the very warm ocean temperatures, I wouldn't be surprised if we're going all the way through the end of November, or maybe even beyond that, like what we saw a few years ago in 2020. In general, I think we could have a lot of season left. And so we'll be watching very carefully.
So one thing that scientists have consistently said about climate change for years is that it's not expected necessarily to increase the number of hurricanes, but it could be increasing their intensity and their duration. Are we seeing that happen this year, or is it impossible to draw conclusions from a single season?
It's very difficult to draw conclusions from a single season, but yeah, we're seeing a couple of things at play here. One is that the extremely warm ocean temperatures that we're seeing are providing that extra bit of fuel. And that extra bit of fuel goes a long way to, helping a hurricane increase its intensity further. There's a balance to that. It's not like, okay, we have more energy in the ocean that automatically means stronger storms. A lot of these hurricanes, the way that they essentially move energy around, a big dependence is what is the difference between the temperature at the ocean surface and the temperature way up aloft at the top of the troposphere, or really at the top of the clouds, pretty much. Some of the outlooks have talked about that storms can be stronger, but we might not get as many. And so this sort of fits into that narrative where, again, if we have really warm upper levels that are helping sort of squash a lot of this thunderstorm activity, maybe that's what leads to less activity overall. But in certain situations, that's not always going to be true. There's going to be scenarios like what happened with Milton in the Gulf, where you have a very warm ocean surface and a very unstable atmosphere that allows for a lot of thunderstorm development. And in those scenarios, once a storm can sort of get over the hump, so to speak, I think we're going to see a lot of those storms get a lot stronger because of the amount of energy available to them.
Well, we know you guys are busy there at NOAA, so thank you so much for being with us here today on the Excerpt, Gus.
Thank you so much. Appreciate it.
Thanks for watching. I'm Elizabeth Weiss. I'll see you next time.